Hello everyone, myself SK Sahil Akhtar. I am a student of college Coachbihar Government Engineering College, and my department is EC. And here is my university roll number, and my subject here is signal and system. And today we are going to talk on the topic classification of signal, which is our CA1 also. And so first of all, I will start from introduction. What do we actually understand by signal? So first of all, a signal is any physical quantity that varies with one or more independent variables and conveys information. Okay, this is the actual definition. But if we try to understand that what actually a signal is basically the signal is basically a disturbance in nature or any pulse created by nature, which we can feel, listen or see. Okay. So first of all, we can see here the examples. The examples are the first example is music. As music creates a disturbance in air, which reaches to our and then air disturbs air particle one by one, which reaches to our ears, which we can listen as music, as speech, or any type of sound. Then ECG. Then temperature means basically the means that the air means the air particle is transferring any type of heat energy or cold energy to nearby particles. Then you can say image intensity. Then here are the mathematical examples. For example, the first one is, we have seen here that x1 t is equal to point t is equal to 0.7 t. You can say that it's a linear signal. That then x of 2t, which is equal to 1.8 t square, which is a quadratic signal. Then x of p comma q, which is equal to 0.6 p plus 0.5 q plus 1.1 q square, which is basically a 2D signal. Then uh, we can say about deterministic and non-deterministic signal. Okay, so first of all, I am going to talk about deterministic signal. So a deterministic signals can be described by mathematical expression, lookup table, or some well-defined rule. So I am explaining this in simple words. In simple word, we can say that a deterministic signal is basically any type of signal which can be predicted at any time, uh, or uh, or about whom we know from earlier, like your sine wave, cosine wave, then square wave, then any type of graph which we know. And here you can see the graph also, the graph of your sine wave. Okay. And which is here your amplitude, and this is your frequency. Basically it's a time period, you and we can reverse it, and we can find its frequency. Okay. Then our non-deterministic signal. So basically our non-deterministic signal, also known as a random signal, on the other hand, are unpredictable with and exhibit randomness in their values. They cannot be precisely described by a single equation, but are characterized by their statistical properties like mean, variance, and probability distribution. Their amplitude cannot be described exactly, involves uncertainty. Okay. So basically the total summary of this uh, we can say that it basically tries to say that whose value cannot be predicted easily, or exact value cannot be predicted, we can say. Like for example, any random ECG signal with noise, then sudden temperature variations. Okay. Then we will talk about periodic and non-periodic signal, or whose second name is aperiodic signal also. Okay. So what a periodic signal is, a signal is said to be periodic signal if it has definite pattern and repeats itself at a regular interval of time. Okay. Means that you are tracking a signal and it is repeating after some time, then we can say that it's a periodic signal. Okay. As we can see here from the name also. Then whose equation is x of t is equal to x of t plus t, because it is repeating. Then it exists if there's a fundamental period, like means t is equal to 0, obviously. Then its example is x of t equal to cos of 4 pi of t, because cos is a periodic function, it is repeating itself. Okay. Then non-periodic oblique aperiodic signal. Okay. This signal which does not repeats a definite pattern after a regular interval of time is known as aperiodic or non-periodic signal. So from the name we can see that this signal which does not repeats itself nor produces a definite pattern is called a non-periodic signal. Okay, so here your x of t will not be equal to x of t plus t as a pattern is not repeating, so then the t must vary every time, sorry, for any fixed t, because this value varies. Then whose example is x of t is equal to e of minus t, because the value is changing. Okay, then we will talk about symmetric and anti-symmetric signal. Okay, a signal which is symmetrical about the vertical axis or time origin uh, is known as even signal or even function. Therefore the even signals are also called as symmetrical signals, whose equation is x of minus n is equal to x of n. Basically we are trying to say that any signal which is mirror image of itself about the axis is called a symmetric signal. Okay, whose examples are cosine wave. Okay, then antisymmetric signal, a signal that is antisymmetrical about the vertical axis known as odd signal or odd function. Okay, which is its second name. Therefore the odd signal is called your antisymmetric signal. Okay, so here x of minus n is equal to minus of x of n. Basically I am trying to say that that anything which is anything that which is mirror image of itself. Okay, so I was talking about anti-symmetric signal. There was some fault in the laptop, that's why the front video cut it. I am starting from the second. Okay, so I was talking about anti-symmetric signal. uh, I have repeated the definition, but I am saying that the that that your anti-symmetric signals, here the sign change the here the sign changes when the figure is mirrored. Okay, so example here is sine wave, because because when you invert the left image, it becomes the mirror image of the right function. Okay, so I was saying that. Then the fourth one is energy signal and power signal. Energy signal, a signal is said to be an energy signal if and only if its total energy is finite, or you can say that calculative. For an energy signal the average power p is equal to 0. The non-periodic signals are the examples of energy signals. Okay, so here you can see the equation which is from minus infinity to infinity, because obviously value can be calculated. You can change its value also, it can be a finite value also. Then here it is a mod of x of t is a whole square dt, which is less than equal to infinity, and here the power is 0. And you can see its graph. Its example is x of t equal to e of minus t ut. Then your power signal, up signal is said to be a power signal if its average power p is finite. Example, um, when your e will be from 0 to infinity, sorry, when your e will be between 0 and infinity. For a power signal the total energy is equal to infinity. The periodic signals are the examples of power signals. Okay, uh, so here your power is equal to limit from t tending to infinity, and here is the equation 1 by 2t integration minus t to t x of mod of x of t is whole square and dt, which is less than infinity. Okay, you can see that. Then here your example is x of t is equal to cos of 2 pi t, uh, and signals with decaying amplitude are likely energy signals. Signals that persist with constant and oscillatory amplitude likely power signals. A signal cannot be both causal. Okay, then I am talking about causal and non-causal signal. Okay, so a causal signal is where the output of system is independent uh, of future values of input. Okay, so basically what we can say that in causal signal the output value is dependent on on your past or present input values. Okay, so here the example is y of t is equal to x of t, because as it is dependent on your present values or past value, and it is written for your present value. and this value is written for your past value. Okay, then we can say for non-causal system, where output of system depends on future values of input at any instant of time. Okay, so we can see here that y of t is equal to x of t plus z, because the z is the future time, and y of t is equal to x of t plus x of t minus 1 plus x of t minus 1, sorry, plus 1. Okay, so thank you for watching my video.